Okay, so we got the insert cut. We want to add some screws to it. Well, we can't add anything when we're active in a mold file, okay? So up here, we want to activate the movable side because that's what we're screwing together, our things inside this one. So here we choose assembly, add from catalog. I've got a lot of screw catalogs, okay? I've got them in DME, PCS, Hasco, standard parts, and each of them looks a little bit different in the bill of materials. I'm going to just take this one, socket head cap screw, coarse thread, and I don't really know what size I want, so I'm going to make a guess. Let's try a 3/8 screw, probably about 2 inches long. Alright, now I'm going to choose place on face, but this screw catalog follows a rule. It always wants to place the screw on the inside of a body from the face that you pick. So what I mean by that is if I pick this face, that screw is going to be going into that plate, so I can't pick this face. I want to hide this face and pick the underside of the gray insert. So over here, I go to my support plate, hide it, roll it up, pick this face, and now it dumps me into the sketcher. In the sketcher, all I have to do is pick on add geometry, and it's going to recognize this as a sketch. Picking one point picks all four. And I guess I'm half retarded today. That's not the right plate. Okay, but we can change it. We're going to choose reselect face. Let's come out of the sketch. Ah, that's pretty cool. It kept everything there, just moved the screws down. Nice. Okay, so the screws are there, and let's take a look at the length. It actually looks pretty good. We can check it in a minute. And of course, we want to place it with a cut. Alright, so let's switch to transparent mode. That's over here. And there we go. Yeah, that looks good. Okay, let's add some ejection while we're here. Now, ejection goes under the ejection subassembly. So I double click on this one to get that active. And then over here on the wizard, we have ejection design. And I'm going to choose add ejector. Now, obviously, I need keyed pins because of the shape here. I believe I have some under my PCS. Yeah, here we go, ejector pin P keyed. Now this is a catalog item that I edited myself to be keyed. So if you don't have one, I can give you mine. And let's see, we'll take a 1/4 inch diameter. And new in version 10, this is supposed to auto measure the length. So I'm not picking a length anymore. It should automatically pick the right length. I don't know if my keyed pins still work that way, but they should. Okay, so I'm hitting OK. It automatically knew what face to pick. Saved me from hiding the ejector plate and picking the retainer plate. And we always place ejector pins without cut because we have a special way that we cut them. Alright, so let's go to the top view and we'll plop a few down. Please don't be too critical of my ejector pin locations. Yeah, actually I am forgetting something here. I just box picked all that and hit delete. We got a new way that we can work with symmetry. Two-axis bipoint. It says pick the symmetry line start point or pick any existing symmetry line. Okay, I think that's right. Now let's see if I pick one here. It should show up a few more spots. Yeah, cool. Seems to take a little while, but saves me from doing it, so I don't mind. Yeah, that might be a problem. A little close to center, and I got both symmetries on. I'm sure we can turn them off, and I'm sure we can spread these apart. Okay, let's get out of the symmetry tool. Alright, and let's see if we can slide these guys up. So the symmetry is maintained too. Okay, that's pretty cool. Alright, and then also I can click this snap on, and that'll give me numbers for each one of these. So I could then make these nominal numbers at whatever increment that I want. So say I want to make them 25 thou increments. I would expect that if I move this one, it's going to move all four, just to get on nominal numbers. And you can also hit this X and you can eliminate that whole ejector pin. So suppose we didn't want these guys, hitting that X right there would delete the location. Okay, so we're going to go ahead and place these pins again without cut. Oh wait, I forgot something again. Let me switch to wireframe. You see the D-shaped pins? If I wanted these to be rotated the same way, say I wanted all the locks to be facing the inside of the mold as these ones are, I can choose group control or individual control, and I should be able to just box pick all of these and spin just those guys by 180. And of course I could pick them individually and just spin one or spin two, but that's a pretty neat way that you have control over spinning them individually. autosave is kicking in. Yeah, check that out. These pins are shorter because they could be. These ones are longer because they had to be. So even though I didn't pick different lengths, the software figured out what lengths went where. And if we look in the bill of materials right now, hold on. Assembly, bill of material. You can see we got different lengths. Here's the P17 pins. We got some that are 8 inches long, some that are 6 inches long. So it's picking the right length pins for us based on the geometry, which is pretty cool. Okay, now we want to trim the pins off to the right height. Again, we use ejector design to do it. Ejector trim. I notice that I'm not in the right subassembly, but sometimes it's kind of forgiving. It might be okay. Let's try it. Okay, so these are the pins that I'm trimming. I box pick and middle pick. I'm trimming by the movable side. The movable side is simply looking at the quilt that we have here, and it knows that the orange faces are the movable side. We could trim by the fixed side. I'm not sure why we'd want to do that, but you can, and you can trim by pick, but 99.9% of the time this will be the right answer. I want a shaped trim, and let's do an offset. Let's say I want the pins to be pushed 15 thousandths into the part to help it ride up better. Okay, so let's go ahead and choose OK. There, it cut all the lengths of the pins, and it left us 15 thousandths proud. Pretty awesome. Okay, now we're ready to key the retainer plate and cut through the support plate as well as the insert. Let's turn on the insert and the support plate. Not that it matters, but I'm just displaying them so that we can see them. Okay, we're going to now choose again ejection design, ejector pocket. In the lower left it says pick the trimming ejectors and then exit. That means that we box pick these guys and then middle click. Okay, now we've got a lot of options here about what's going to happen. This picture tries to demonstrate the various options, but we can control a constant land around the pin and then have the clearance depths be all different from the back side, or you can go to the shallowest depth or the deepest depth. There's a lot of options here. I don't hardly even remember them all, but just use this picture to see what you're after. Normally the constant fit length is a pretty good one. It's just going to give us 3/4 of land around the pin and a diametric clearance of 1/32. Okay, and then down here you got an optional step. Every once in a while there can be an issue where it might be looking at other bodies. Say that we had a slide in the B side. If I pick this option, I don't want to see that slide lighting up in red. I don't want it being considered. So only things that should be picked right now are the insert, the support plate, and the retainer plate. If I had some other body being picked right now, it could be an issue. Okay, let's see what happened. I'm gonna, oh yeah, here's something. Watch this. I'm clicking on this over here between transparent, wireframe, and solids, and nothing is happening. The reason nothing's happening is because over here I've got this set to solid, and it just means everything's in solid state, like transparent is turned off. This one is called mixed, so if I pick this bottom one, it then looks at the attributes over here to see what to show me. So again, wireframe is just wireframe, shaded is just shaded, but mixed looks at attributes over here. And here we can see that we got our 3/4 of land around the pin and clearance below that. And let's see what our retainer plate looks like. I want to hide this plate. I don't have to go over here and look for it. I can just pick on one surface in that file and hit hide. And because I'm at the assembly level, not only is that surface going to hide, but the whole file. Okay, here's all the keyed pins. And of course we got the clearance through the support plate as well. And this makes short work for auto drill. Our automated drilling is really nice for picking this stuff up automatically.